Hello, my name is Lino Grandi and I'm a 3D artist at OTOY. In this video, we'll be going through the basic of Octane's Toon material and how it can be used to get some nice anime style look. Octane is very famous for its photorealism and speed, even if you're using just one graphic card. In this case, I'm using a Quadro RTX 5000, the one available on the laptop I'm recording this video with. Octane offers an extremely interactive real-time experience with photorealistic scenes, and this feature really shines when toon shading is involved. Let's get started. Let's select our model and assign new Octane material. We can already start the Octane preview render. A universal material has been assigned by default. We need to change it into a toon material. To do that, we can click on the Universal Material button and simply press T. That will replace the current material with the Toon Material shader. Of course, it's also possible to just add a new material directly in the node editor and attach it to the material output. We already have one attached, so we can get rid of the one we just added. To be able to work with the Toon material, we need a special Toon light. We already have a point light in the scene. Let's change it to Sun and click on Use Nodes. We can now use the light direction to control the lighting of our mesh. It is also possible to use the no direction option, but in general I prefer the default option since you can visually check the relative orientation of the light in the scene. Let's select the model again. We can use the diffuse option in the Toon material to change the shading color. Let's set it to pure white and add a Toon ramp texture. We can connect the ramp to the Toon Diffuse ramp input to better control the final shading. Moving the keyframes close to each other can help getting rid of the 3D shading effect. We can change the color of each keyframe to control the shading. Getting the two keyframes close to each other is an option, but the best thing to do to get a sharp termination between different color areas is to change the ramp interpolation from linear to constant. Let's change colors, assigning a dark blue to the first keyframe and a lighter blue to the second one. We can change the specular intensity using the specular option, while roughness controls the size of the spot. Even in this case, we can use a Toon ramp to better control the look of the specular highlights, simply attaching it to the Toon specular ramp input. Let's change interpolation to constant. We can now add more keyframes and get some more complex specular. Thanks to the specular ramp, we get total control over the position and color of the Toon highlights. We can detach the Toon ramp from the specular input since for this model the basic settings are all we need. Let's set the roughness to a value close to 0.1. From the kernel settings, we can access the Toon Shadow Ambient option. We can use it to change the general color and intensity of the shadows. Setting it to black will also make shadows totally black, while a white value will totally make them invisible. A middle range gray will work great for us. It is also possible to switch from the Toon Light to Camera Light mode. In this mode, the Toon Light effect will be totally ignored, and the camera will be considered the source light. It can be useful sometimes, but not in our specific case. Let's adjust the light orientation in order to get a more pleasant effect on the model. We can now select our model again, so to be able to further edit the shading and work on the toon edges. We will change the edge thickness and color. This option works quite nicely on this kind of very organic meshes. It's using the incidence angle for the scope, which can be not ideal for flat surfaces, where you can easily get some extended and undesired dark areas, as the cut on the arm clearly shows. We can limit the issue setting the outline thickness to a very low level, but that will also limit the general edge thickness. Let's use a value of 0.3 for it. We'll use the dirt texture to create some nice additional edges. Let's plug it in the diffuse input. The dirt texture is basically an advanced occlusion shader. His effect becomes clear as we play with the strength. Let's set the strength to 10, details to 100, radius to 0.5 and radius map to 0.05, and tolerance to 0.1. Those are the perfect values I found for this model and can be a nice starting point for any other situation. I really like the way the dirt texture can successfully trace edges for this mesh. Let's change the light orientation again to create some nice lighting. In camera mode, let's choose a good view angle. I'm going to add some out of focus effect. That's not something often used for anime, but it can really add some more depth to the character. To do that, all we need is changing the aperture of the camera. A value of 45 works great in this case. Something I really love about Octane is the control you have over every aspect of the final image through the camera imager and the post-process options. After activating the camera imager, we get access to many film presets. In this case, I'm choosing this profile, which provides some good color correction and contrast. I'm also raising up the gamma a little bit to make the image brighter. Let's activate the Octane post-processing and set the bloom and glare power to 10. We can play with the settings until we're satisfied with the final result. The dirt procedural texture is one of the best ways to get some very nice Toon edge effect when dealing with geometric shapes with very sharp corners. I've generated this mesh using the box cutter add-on. Let's turn on the Octane preview. The Toon material is set up already, and the Toon directional light is used. If we try to use the outline thickness option, that's not going to produce what we need, since as we mentioned already, it's not ideal for flat surfaces. Let's set outline thickness back to 0 and add a dirt procedural texture connected to the diffuse input in the Toon material. Let's set strength to 10, details to 100, radius to 0.02, and we'll get some nice edges on the convex corners. We can use the radius map as an additional way to control thickness. A value of 0.3 looks fine to me. Inverting the normal will trace concave corners instead. Since we need to trace both, let's duplicate the dirt procedural node, invert normal on the first one, and add a multiply node. After connecting the multiply node to the diffuse input and the two dirt procedural nodes to the multiply node itself, we'll get both convex and concave corners correctly traced. The final result is definitely good, and using this edge rendering technique in animation is really satisfying. Now, simply connecting the output of the multiply node to the opacity and then adding an invert node, we can make the whole mesh totally transparent, just keeping the edges visible. Let's detach the invert texture to get rid of transparency and go back to full solid view, and let's make the OpenGL overlay visible again. Let's add a 64 vertices cylinder with a 0.5 radius. Let's scale the cylinder and move it so it's intersecting the main mesh. You can see how the intersection between the cylinder and the mesh gets traced, and we can turn off both camera and shadow visibility to totally hide the cylinder. We also have a dirt visibility control that let us decide if an object should participate or not to the dirt node effect. We can now simply clone the cylinder multiple times and draw as many intersections as needed. That's another very useful trick if we need to draw complex edges on a mesh. We already know outline thickness can often create unwanted black spots. We can decrease the thickness value to limit that effect, but that's going to reduce the edge thickness for the whole model as well. Let's increase the thickness value again. I'll detach the Toon ramp texture and the dirt texture to better see the effect of outline thickness. The dirt node is not useful to get proper silhouette edges, but we can use a pretty popular technique mostly used in video games called inverted hull. So let's set outline thickness to 0 and then create a copy of the mesh. Let's rename the copy as alien bust edges. To simulate the inverted hull effect, we'll add the solidify modifier. We can hide the other mesh for now. I will set the offset to 0 and thickness to 0.05. This will expand the model along its normals. Also, let's turn on flip normals. We need to create an additional material slot and assign a new material we'll use for the edges. I'm pressing T to replace the universal material with the Toon material. Let's make the diffuse black. After adding a polygon side node, let's connect it to the opacity input in the Toon material. You'll see no difference. Let's go back to the solidify modifier and change the material index offset to 1, so our edge material will be used for the solidified part of the mesh. Now the outline is visible and it looks really nice. We need to solve an issue here. As you can see, the color is different than what we defined initially. It looks way darker. That happens because of the inverted normals. The only way to solve this is to turn off shadow visibility for the solidified mesh. The color issue has been solved, but now the model is not showing any self-shadow. Let's take the model back to the origin using Alt and G. We now have two overlapping meshes, and we're getting the outline edges from a model and self-shadowing from the other. We can now attach the dirt and Toon ramp nodes again to get the final effect, a Toon shaded model with perfect outline edges. Setting the radius map to 0.5 will reduce the edge thickness, We can also play with the thickness value in the solidify modifier to increase or decrease the outline edge thickness. Since I wanted to recreate the look and the sense of action of a typical anime, I created this scene in Octane for Blender. The design is definitely inspired to Macross, one of my favorite OAV. For this shot, I've used Octane post-process effects and depth of field, which is unusual for this kind of style, but I like the effect anyway. Still, Octane is able to play the scene in real time at a very high frame rate, using just one Quadro RTX 5000. Let's stop the playback and hide the two aircraft instances and the environment collection. I've created an empty which is the parent of all the elements relative to the jet. It's what I've used to animate the aircraft. Let's hide all the parented items so we can examine them one by one. We have the mesh with no edges applied used to get self-shadows. Then we have the mesh with the solidify modifier applied to get the inverted hull effect. That's the solidify modifier all set up as described previously. So again, the mesh on the left shows self-shadows, while shadows are completely disabled on the other mesh. This one is showing edges created using the solidify modifier and other techniques we'll describe later in this video. We also have the jet edges mesh, showing an additional way to create edges for the model, this time using curves. Let's select the mesh and press Alt-G to bring it to its initial position. Let's do the same for the other mesh as well. Let's press 0 on the numeric pad to switch to perspective view mode. This will disable the Octane post effects I have activated for the camera. We'll use a technique involving grease pencil to create the edges. Let's add a grease pencil blank item and press Alt-Tab to go into draw mode. Be sure to be using surface mode so the strokes will follow the mesh geometry. Let's assign a material to grease pencil. We can now start to draw strokes on the side of the aircraft model. Let's apply a grease pencil smooth modifier and let's increase the step value up to 10. Let's press Alt-Tab again to go back into object mode so to be able to see the modifier effect. Now the edges look way smoother. We can now apply the smooth modifier. With the grease pencil item selected, from the object menu, let's select Convert to, choosing Bezier Curve. A new curve will be created. Let's rename it GP_layer_edges. Now, from the curve options in the Geometry tab, let's add some depth to the curve. A value of 0.012 works great in this case. To get rid of the shadows projected by the curve, we need to disable Cast Shadows from the Object Properties tab. Let's press Tab to go into Edit mode. We'll notice the curves are composed by a very high number of points. From the Curve menu, let's select Clean Up Decimate Curve. We can now adjust the ratio, decreasing the value. Decimate Curve is using a smart algorithm which deletes points selectively, trying to keep the shape of the original curve intact. All curves are showing the same thickness right now. Let's see how we can control it. We'll do it using another curve. Let's add a path curve and move it so we can actually see it. Let's select the previous curve and let's select the path as taper object. The edges will become barely visible now. Let's select the path curve and hit Tab to go into Edit mode. We can now move the points on the y-axis to define the thickness of each curve in the GP layers underscore edges curve. The path length represents the length of each curve we're using to simulate our edges. The start and end points of the path are controlling the start and end points of each curve in the other layer. The y position of each point will define the relative thickness of the edges. We can add a mirror modifier to add the missing curves on the other side of the aircraft. And of course we can always use the depth value as a global control for the curve thickness. Another method we can use to create Toon edges is through vertex maps. I created this very simple wing model and I'll be using vertex maps to draw some edges on it. Let's hit Tab to go into edit mode and double click on the edge to select the edge loop. We can add this edge to get the whole loop selected. From the object data properties, we can now add a new vertex group. We can rename it to edges and assign it to the current selection. If we switch to weight pane mode, we can see the sine group marked in red. Let's go back into preview mode. Let's add a float vertex texture node and edit the name using the vertex group we created, which is edges. After connecting the node to the diffuse input, we'll be able to see the effect of the vertex group. Since we want a black edge, we need to invert the effect using an invert node. That's not enough. We need the edge to be sharp, so let's add a gradient node. Let's change it from linear to constant. Now we can edit the gradient keyframes to control the edge thickness. Since we're using a gradient now, we can get rid of the invert node and just invert the position of the keyframes in the gradient. One thing we need to be aware of when using this method is that the thickness is influenced by the surrounding edge loops. We can solve this pretty easily. Let's select the edge loop again and remove the edge vertex group. Let's hit Ctrl B to bevel the edge loop and also use the mouse wheel to add a subdivision. Now let's select the middle edge loop again and assign the vertex group. In this case, we need to adjust the position of this vertex so the distance from the surrounding edge loop is constant. Let's add another edge, crossing the previous one. I'm selecting the whole loop and applying a bevel, just like before. We can now select the middle edge loop and assign the vertex map. We can see an artifact just where the two edges are crossing. That's due to the way vertex maps work. We can solve this easily. Let's undo the vertex map assignment and create a new vertex group named edges_02. Let's assign it to the selection. We can now duplicate these two nodes and change the name from edges to edges_02. We'll be using a multiply node to merge the two vertex groups. Now we have two independent edges generated by two independent vertex groups. We can of course edit the vertex maps to control where the edge should be drawn or not. I'm selecting some points I want to remove from the vertex map. After selecting those, let's click on Remove in the Vertex Group panel. I still have a segment left, but I'll keep it for now. Let's select this edge loop and apply the bevel, just like we did before. Then, after selecting the middle edge loop, we can assign the vertex group. Let's also select this edge and assign the vertex group to connect the two edges. I want to add a white stripe in the middle of the wing. Let's assign those two edge loops and apply the bevel. Then we can select the two middle edge loops and assign the vertex group. We need to assign a new material to this poly loop. I'll create a new material slot and assign the wing material, then create a copy of it. Now we can simply change the colors in the gradient. I want this edge to be thicker, so to match the thickness of the others. So I'll select this edge loop and double press G to slide it, and then do the same for the other one. I'll add a solidify modifier to simulate edges using the inverted hull technique we already described. We know the steps needed for this already. First, we add the solidify modifier with flip normals on, and we specify offset and thickness values. Then we create a dedicated material for the edges with a polygon side node connected to the opacity input. We specify the correct material input offset so solidify is using the edges material. Finally, we disable shadow visibility for the mesh. As we add a modifier to the mesh, we're losing the possibility to use the vertex maps, which right now are not visible at all. To solve this, we need to add a vertex weight edit modifier and specify the name of a vertex group. Let's add a subdivision modifier and let's move it between the solidify and vertex weight edit modifier. Using subdivision for a Toon shaded mesh can definitely improve the final shading. Let's go into edit mode pressing tab and hit A to select all. Since we don't want to completely lose the sharp corners in our model, we can change the mean crease value for all the edges to 0.9. Let's rotate the light so we can take a look at the specular highlight. As we can see, the specular highlight is covering the edges. We can solve this connecting the multiply texture node to the specular input in the Toon material for both surfaces. Now the edges will always be visible. To give a dynamic impact to the scene, I created an animated background composed by several elements like kinetic lines and stylized clouds. In the last part of this video, we'll describe how these effects have been created. Let's start with the kinetic lines effect. I'll add a simple plane to the scene and assign a Toon material. Let's turn on the Octane preview and add a noise texture attached to the diffuse input. Also, let's select the lamp and click on Use Nodes to convert the sunlight into a Toon directional light. Let's add a 3D transform node and let's connect it to the transform input of the noise texture. I'll change the scale value so we can get a very stretched texture. Only X and Z values really matter in this case. Now let's increase the contrast. Decreasing the gamma will make some parts of the texture disappear, creating a more random effect. Let's make the plane bigger. I will add an invert node and connect the noise to it, and then I'll connect the invert node itself to the opacity of the Toon material, so to make the background of the lines transparent. It's time to animate the effect. To do that, we'll be using the Z translation channel. We can scale the texture so to get a pattern we like. Let's be sure we're at frame 1, right-click on the Z translation channel of the 3D transform node and insert a keyframe. Then let's move to frame 250 on the timeline. We can now insert a new keyframe right-clicking on the Z translation channel of the 3D transform node. I'm using a value of 500 meters. Of course, bigger the number, faster the texture movement will be. Let's right-click on the channel and select Replace Keyframe to store the new value. The current animation is not linear. To make it so, we'll use the dope sheet. Let's click on the node. The keyframes we created will be there. With those selected, all we need to do is pressing T while on the timeline and select linear. We can now press the bar to check the result. No acceleration or deceleration, just a constant speed. We can create stylized clouds starting from this setup we just created. First, let's work on the scale values in the 3D transform node. I'll change X to 10 and Z to 350. I'll duplicate the invert node and use it to invert the texture in the diffuse node. From the Word Nodal editor, let's add a texture environment node connected to the Octane environment input in the Word output node. I'll change the color to a light blue to simulate the sky. We can play with the noise options in real time while the animation is playing to get different effects. We can change the omega, the number of octaves, or the gamma. We can also duplicate the object and create a copy of the material to add some depth to the effect. I'll change the color to orange using a Toon ramp. We can also edit the scale value to add even more variation to the final effect. In this video we went through some of the powerful tools in Octane for Blender I've been using to create this anime style scene. GPU Render and NPR are a magnificent couple for sure. The Octane render engine is extremely responsive on the Quadro RTX 5000 I've used to record this video, which makes experimenting with the various settings a very fast and pleasing process. I hope you enjoyed this tutorial and found it useful.